Hi, class, and welcome to CIS 150 Intro to Networking. I'm Mr. Wallington, Larry Wallington, your instructor, and this should be a fun class. It's intro to networking. I want to keep that in mind. I know some of you guys out there just looking at some of the discussion posts. You've got some background in networking, so this will be a refresh for some. I know for some, it's probably going to be your first time being exposed to networking. That's why I put this little PowerPoint together. I talk about keeping it simple, because you see sometimes it can be very when you think about networking, it can be overwhelming. Now that's why I give you what I call life according to Mr. Wallington. Yes, you get philosophy as well, not only networking but philosophy also. You know what? I believe that there is nothing hard on this planet. Anything that we think is complex, really all it is a lot of simple concepts working very closely together. Networking, the internet, all of these things, it's the same way. Very simple, and actually some very old concepts that were really came about back in the 60s and 70s, and even some back in the 50s. So it says there's nothing new under the sun. I think somebody wrote that one time, and it isn't. So what we see is some of the old concepts that we just keep building on, and that's how networking goes together. As a matter of fact, after we talk about the OSI model, we're going to jump into, because I like to use this analogy of the US Postal System, because really that was one of the first networks, and the internet that we use today is still kind of built on the same concept of the US Postal System. Now, when we think about any type of network, any type of infrastructure, it has to have some way of communicating or protocols. And that's what the OSI model, the Open System Interconnection model is. It's just a way that we can send information between two computers, between the different layers. And it's just an architecture, because all these things you can't physically reach out and touch, but they exist as an architecture to show you how, as a data model, of how data flows through a network. Like I say, there's 7 layers to the OSI model. There's a TCP/IP model, and there's 5 layers to that. For simplicity, we're just going to talk about the 7-layer model. And really, actually, for this particular presentation, I'm really just going to focus on the first 3 layers: the physical layer, the data link layer, and the network layer. And if you look at this little column over here, all people seem to need data processing. That is a great way to remember the different layers of the model. But yeah, our focus right now is just really going to be on those first 3 layers: the physical, data link, and the network layer. And the protocol also tells you kind of what is at each level, what the information looks like, what the data stream looks like. Physical layer, we're talking about bits of information, kilobits, megabits of information. At the data link layer, it's frames. It's how things are encapsulated. We're going to discuss encapsulation. And at the network layer, we're talking about packets. And I like to talk about packets because that's a good segue into the US Postal System, because we mail things like packages. So kind of get an idea. So let's talk about the postal system. All right. I love teaching in analogies. And if I can always find an analogy, hopefully sometime I think it helps people who may not have a grasp of what's going on to bring them up to speed. All right, so here I am in Newport News. I'm really not in Newport News. I actually live in Texas. I used to live in Newport News, but now, so if you go through 225 Lynn Drive, you will not find me or my wife there. But for purpose of discussion, my house is at 225 Lynn Drive, Newport News, Virginia, zip code 23606. My beautiful dear grandmother lives at 225 Patty Street in Newport News. And I love my grandmother, and I love mailing letters to my grandma. So if I'm going to send her a letter, there's something I've got to do. I've got to address an envelope, and I think we all know about that, right? We've got to have a return address and a mailing address. Same thing in networking, except we call it a source address, so like a source IP address, and a destination address. So you see the concepts very similar. They're all kind of built on a very similar concept. And like I say, but with networking, instead of using, a written text, we use different protocols. We currently work with IPv, Internet Protocol version 4, moving to IPv6. But for simplicity's sake, we're just going to stick with version 4. And so it uses groups of numbers, binary numbers, 4 groups of 8 binary numbers to represent an address, an IP address. So if I look at this number right here, all these ones and zeros, that long string of ones and zeros, wow, pretty hard for humans to read that. What if you had to tell somebody, they actually, well, what's the IP address? And you had to tell them 11000101011000 and on. They'd be like, whoa, too much information. So what do? We convert that to a decimal, or we call it dotted decimal, which makes it easier for us as humans to communicate what an IP address is. So when we say 192.168.1.15, in effect, the computer doesn't have a clue what that is, but it does recognize this. And that's what that conversion is. So when you think about these 4 groups, what we do is a binary conversion on each group. So 192 converts to this in binary, 1, 1, and then 6 more zeros. 168 converts 1, pretty simple, 7 zeros and a 1 and 15. So we do that conversion. So when you tell somebody your IP address, 192.168.1.1, or in effect, this is what you're actually telling them. So you see the similarity between the addressing scheme, between the letter and how we have to write an address for an IP address, so the computer knows where to send and to route things through your network. So I want to mail my mother a letter. Well, what do? My grandmother, I'm sorry. I address the envelope, and it goes on a little truck, and that little truck takes it to a post office that's not too far from my house, the Newport News Post Office. What do? Well, first thing they do is, let me back up, because those trucks that just took my mail, they represent the physical layer. So when we think about the physical layer with the mail system, yeah, that's trucks traveling over the highways, or the humans walking from door to door. With layer 1 in the ROSI model, and with our network, that's copper cable. We're talking about fiber optics and Wi-Fi, Bluetooth. All of these things are your layer 1s, the physical layer that connects your network components together, just like the highway and the road system connects it so that the mail truck can get to the post office. So when the letter gets to the post office, using layer 1, the post office, what they do, they look at this thing we call a zip code, a zone improvement plan. That's what ZIP stands for, by the way. Zone improvement plan. They look at the zip code of the source address and the destination address. And they say, wait a minute, this is a very similar zip code. Actually, these are the same. So that means that, you know what, this is a local area network. They both reside on the same network. So the post office can then just put it on another truck via layer 1 and send it directly to my grandmother's. And she gets the letter, she opens it, and she reads it, and she is ecstatic to hear from me. So the post office, what it's acting as, is layer 2. That's a layer 2 device. So it's analogous of a switch. And what does this switch do? Well, it connects hosts together. And think about my grandmother's house and my house as 2 hosts. Sometimes we call them clients. Well, that's what that post office did logically, using the physical layer. It made a delivery path here to post office there. This device down here in the picture, which is a switch, this is a 5-port switch. Actually, and that's what it can do. It connect up your computer, your printer, and all those different things can be connected right to the back of the switch, and they can all talk to each other across layer 2. So just same analogy. So in fact, what I've done, like I said, with the post office, they built a nice little LAN, a local area. No different than in your house, you have a LAN also, local area network. If you've got, I don't know, maybe cable or Vios or whatever, if you look on the back of that, you probably see a little 4 or 5-port switch on the back of there. You can do the same thing. You can plug all, if you wanted to run Cat5 Ethernet cable or Cat6 in your house. So you could build that in, and you could talk to your own little network. Okay? Well, here's what happened. My grandmother, bless her heart, one day she came to my house and she was listening to my old school rap CDs, and she found this old CD by LL Cool J that says, I'm going back to Cali, Cali, Cali. Okay, bad. I know, bad. And it probably went right over the head of a lot of young guys. Sorry. Anyway, she up and moved to California. Yes, she went to 345 Sunny Beaches Cove, Los Angeles, California, 90210. But I still love my grandmother, so I still want to mail her a letter. So, but what has to happen now? Because now she is no longer in my local area. She has left my local area. So now when I send this letter to the post office does the same thing that it always does. It looks at the zip codes and it says, wait a minute, 90210 is not a local code or a local address on my network. So then what does it do? Well, it already has a path that it understands that, you know what? I need to send this mail to St. Louis. So it goes to the postal hub in St. Louis. And then St. Louis looks at it. Oh, okay, it's trying to get to 90210. I think that's out there on the West Coast somewhere. So it does the same thing. It says, well, you know what? The closest route that we have established is San Bernardino. So it sends it to San Bernardino. Now that's not too far from my grandmother's house, which is that's back into a local area, which they put it on a truck and gets it to my grandmother. She opens the letter, reads it, and we're happy again. So what did we just do? Well, if you think about that St. Louis postal hub, it's operating as a layer 3 device, a switch, a router, or a layer 3 switch, because you can have both. Now, what device is doing, it's actually routing or connecting disparate LANs. Here's what I mean. Look, if you look what we got, like I said, I've got my local area here that I'm used to mailing stuff back and forth. After Grandma moved, she is in this local area. So we got 2 LANs, 2 local area networks that are not connected, unable to talk to each other until we bring a layer 3 device, a router. Purpose of that router, it is to connect this local area with this local area. Now we have a means of getting mail across the country because the router, it does the routing, just like with your network. That's why in your home network, you have a router. You actually have a router and a switch. But the router, what that router does, and if you have BIOS, it's a device that probably stands up about this tall or it may lay down, but it is connecting your home local network to the Verizon wide area network through the internet service provider. And that's why they're called the ISP. But they do that routing. And that thing in a device in your house, that's what it does. It's a router. So it's connecting those 2 disparate networks. You could unplug your router and your home network. You can still talk from device to device in your own home, depending on how your network's set up. But you would not be able to get out to the internet and do anything else. That's why if you have, say, a wireless printer at home or even a wired printer, you can still print, even if the internet goes out, right? Let's say Verizon, boom, somebody comes and cut the fiber optics cable. So you have no connection. So this link to the router is broken. You can still print on your printer, correct? Because that printer is part of your LAN, your local area. Has nothing to do with going outside of that. Now, let's say if your grandma wanted to print on your printer across the internet, which you can do now. I'm sure you all know that you can set up a device to print that way. Well, then now that would have to be a pathway, and that router is what was set up, the IP pathway from her computer on her LAN, local area network, through the router that sends it and routes it. No different than the mail does. And if you ever think about mail, this post office here, it knows all the different routes. It learns all the different routes to get to all the different post offices around the country. Make sense? Of course it does. Okay, now, for me to get this letter, my letter, to her, well, they just don't take a single letter and just, you know, fly it over cross country. No, that's very inefficient. We use something called encapsulation or decapsulation, and that's where these two terms are very prevalent within the OSI model, because within each layer, there's that process of encapsulation and decapsulation. Let me give you an example. Here we go. Let's go back to our mail system. So when I wrote this letter, the first thing I had to do was what? I wrote a letter on a piece of paper, folded it up, stuck it in an envelope. So I put my letter in the envelope. That's the first layer of encapsulation. That letter is encapsulated inside of the envelope. When the truck took it to the post office, guess what they did? They took my letter and everybody else's letter that was out there in this local area, and they put all these in a big bag. Okay, so now I have a letter encapsulated in a letter encapsulated in an envelope that's encapsulated in a bag with a lot of other letters. Well, to get that to St. Louis, they took that bag and lots of other bags with letters in it, and they put them on a big pallet, and the pallet went into the back of the aircraft. So here again, encapsulation. Letter and an envelope and a bag, a lot of bags on a pallet on aircraft. Aircraft goes now on the other side, we're going to start the de-encapsulation process. So I got the pallet with all the bags, with all the letters and stuff inside of every envelope. It got to the San Bernardino post office. They broke the pallet down, took the bags off, and based on how they were addressed there, because they put a header on each of these as during this encapsulation process. There was a header, there was a label that says that these all need to go in the similar direction. And when it got here, some of these bags may have gone to Los Angeles, some of them may have gone to San Diego, some may have gone to Burbank. So each bag knew where it was going to go. Mail system uses zip code. We use headers on our IP address to do that same thing. So now the bag, the bag that's got all the envelopes that got there, and now they break that bag down, put it on the back of a truck. That now I got a letter, envelope, goes to my grandmother. She opens it up, pulls the letter out. So we encapsulate it and we de-encapsulate. Okay, so how does that play out? That's what happens in each of the layers of the OSI model. All right, let's say you're watching your keyboard cat video. I hate that video. Hated it. But anyway, while that YouTube video for you to, and you want to send it to someone, well, at each layer of the OSI model, there's a header, just like an address label. Think of it as a label. Stick it on there and put it in a box with a label. Next layer, take that box, put it in another box, and put a label on it. And each one of these labels tells it what's different types of information that says what that header needs to do. For instance, here, this is layer 4, TCP. That's your transmission control protocol that controls how your packets are segmented and sent out. When you get to layer 3, it puts it, so you still have the application header, you still got the TCP header. Then on top of that, it puts an IP header, which is your internet protocol for routing. Okay, there's the address, and it puts that on top of that. And then at layer 2, it puts an Ethernet header. At layer 2, we're going to get a little deeper into that when we talk about switches. It uses an Ethernet header that's part of the media access control of the MAC address. And then that's what prepares it to go onto copper cable or fiber optic, and is converted to electrical impulses and energy that can be transmitted long distances. So, and then on the other end, the exact opposite happens. That electrical impulse comes in through your fiber modem or through your Ethernet modem, comes in at layer 2. It reads this information, strips the header off, sends it to layer 3, reads that information, strips the header off, goes to layer 4, reads that, strips it off, sends it, and now, boom, it shows up on your computer. You see it as your keyboard cat playing. Okay, so that was a quick walkthrough of an analogy of how everything that we're doing here in the internet, and some of it seems really fascinating and some of it seems like really mystical, but it was all built around a very foundational, a very simple concept of how the US Postal System sends a letter from point A to point B and routes it and does all those things with headers and addressing and things of that nature. Okay, so something that sounds and looks really complex really is a combination of a lot of simple things, and we're just going to break those simple things down over the course of the next 5 weeks. So what did we discuss today? Like I said, we talked about layer 1, the physical layer, layer 2, your data link layer, and layer 3, your network layer, as well as encapsulation. Hey, I hope this made a little sense to you. Hope it will highlight a little bit better if you're not already familiar with the OSI model and how networks basically work. Okay? See you next time.